In this video, we're going to tackle task 7. Task 7 is calculating the cumulative incremental net monetary benefit. And this is a really useful thing to calculate. It will allow us to plot things like the break-even curve. It will allow us to determine how long it takes for treatment B to represent good value for money. Does it ever represent good value for money? But if it does, how long does the time horizon have to be before we break even with treatment B? So not every model calculates the cumulative incremental net monetary benefit, but it is something that I think is quite useful to decision makers, and so we're going to calculate it here. And you should think of the cumulative incremental net monetary benefit as the sum of the incremental net monetary benefit for all cycles from 1 up to n, where n is the time horizon. And the reason that calculating cumulative incremental net monetary benefit can be quite difficult is because we need to account for the half cycle correction. Remember, in previous tasks, we've had to account for the half cycle correction in that total cell. If I go back to, let's say, the incremental outputs here, we've had to calculate the account for the half cycle correction here in the total. Same on the discounting sheet, same on the incremental net monetary benefit sheet. Well, we have to account for that half cycle correction in every single cycle on the cumulative sheet, because each one of these can be interpreted as the total incremental net monetary benefit if the time horizon was the corresponding number of cycles. So if the time horizon was just 3 cycles, well then what is the total incremental net monetary benefit? That's what we need in this cell here. And what about 4 cycles, 5 cycles, and so on? So this is a little bit more difficult. There's another challenging formula that we need to use. And step 7.1 is to enter this formula. We're going to throw us straight in the deep end. There's only one real step in this task, and then step 7.2 is just to compare the instructor's formulas to your own. So one very, very difficult step in this task. And there's a hint here. You may wish to construct a formula that for cycle n reads the cumulative incremental net monetary benefit for the previous cycle. So let's say that we're talking about, n equals 3. Well, we're going to read in the cumulative incremental net monetary benefit from cycle 2, that's n minus 1, and then adds the non-cumulative, so just the incremental net monetary benefit for cycle n for this one, right? So we just read in the cumulative for this, and then we add what the incremental net monetary benefit is going to be for this cycle, right? That's the kind of logic that you want to be doing here. However, you need to account for a half cycle correction in doing this. So without a half cycle correction, this one is just going to be the incremental net monetary benefit for cycle 1. That's easy. And then this one is going to be this plus the incremental net monetary benefit for cycle 2, and so on, right? So it's fairly straightforward. But with the half cycle correction, it's a little bit tricky. And the way I would think about this is, let's say, imagine that n is 1. We have a time horizon of just 1 cycle. After you apply a half cycle correction, you're going to want to take half of the incremental net monetary benefit for cycle 1 and add on half of that for cycle 2, right? That's if you had a time horizon of just 1 cycle and you're doing a half cycle correction. You take half of cycle 1 and add on half of cycle 2. If you were to then move from n equals 1 to n equals 2, what would you do? You'd now be having half of 1, but then all of cycle 2 and half of 3. And if you compare those two things, what changed? When n was 1, we had half of n and then half of n plus 1. When n was 2, what did we add on? We added on the other half, the remaining half of this cycle, plus half of the next. And that's going to serve us well for writing this formula. Okay, as we increase n, as we increase the time horizon, each time we need to take the cumulative incremental net monetary benefit from the previous cycle and then add on half of the incremental net monetary benefit for the cycle in question plus half of the next. Right, that's all we need to be adding on each time. So when we get to cycle 3, we just need to take the cumulative from cycle 2 and then add on the non-cumulative, half of that for 3 and then half of it for 4. Okay, sounds complicated. Let's have a go at writing this. The other minor complication we need to deal with is if we are pulling the cumulative in from the previous cycle, that's all well and good, but what do you do for cycle 1? You can't pull anything in from the previous cycle. You don't want to be referencing this cell here that says current value. So we need to do something slightly different for cycle 1. So there's a lot going on here. So let's get started. We need to do a formula. And we're going to start with an if statement, and we're going to talk about, and we're going to look at whether there's a half cycle correction, because if there is, that changes our calculations. So if S in a half cycle correction equals yes, okay, this is the more complicated one. We'll do that first, and we just have to remember at the very end of this to return, we need to do a comma and then deal with what happens if this is false. What happens if it's not a half cycle correction? That's a lot easier, but we'll deal with that at the end. So with a half cycle correction, the first thing we need to do is pull in the cumulative incremental net monetary benefit from the previous cycle. Now, obviously for cycle 1, we don't want to do that, but we do for all the other cycles. So if the current cycle is 1, we want to start with a baseline of 0. And if the current cycle is anything other than 1, we want our baseline to be the cumulative from the previous cycle. So how are we going to do that? We can do another if statement. And this isn't a nested if statement at this point. It's an if statement within an if statement. So if, now, where's the cycle number? It's in D22. And I'm not going to lock this with an absolute cell reference. I want this to change to E22, F22, and so on. So D22, if that equals 1. So that's our logical expression. If the cycle is 1, then comma, I want us to start with a baseline of 0, so just 0. And then do another comma. Otherwise, sorry, there we go. Otherwise, I want us to start with whatever is to the left, one cell to the left. And so that's going to be C23. We're not going to use C23, of course. If we are in D23, we pull in 1 and we're going to use 0. But once this gets copied across to, let's say, E23, well, then this is going to pull in D23, right? I hope that makes sense. So we're going to close the bracket on that nested if statement. So what that does is it pulls in the cumulative net monetary benefit so far, right, up to this cycle, right, that was calculated in the previous cycle. Now, what do we need to add to this? We need to add half of the incremental net monetary benefit for the cycle in question, and then half for the next cycle. Okay, so we're going to do 0.5 multiplied by the incremental net monetary benefit for which cycle? Is going to be the same one. So just in this case, it's 1. It's D23. It's that one there. And then we need to add on another 0.5 times the incremental net monetary benefit for the next cycle. So that's E23. Okay. So that's what we do if there's a half cycle correction. Now, what if we don't? So I'm going to do a comma. And this brings us back to that very first if statement. We're now dealing with what if the logical expression is false? What if half cycle correction is not yes? So in that case, we want to do, do you remember this part here where we were taking the cumulative incremental net benefit so far up until the previous cycle? I'm going to take that bit of text, I'm going to right click, copy it, and I'm going to go to the end here and I'm going to paste it here. So we want to do that. And then what do we do? So that, without a half cycle correction, that is giving us the full incremental net monetary benefit, in every cycle up to the previous one. We now, because there's no half cycle correction, we need to add on the full incremental net monetary benefit for the cycle that we're now up to. So we're going to add on, we'll go back to, we're still on the incremental net monetary benefit sheet. We're going to add on just this one here. So D23. And then we're just going to close the bracket. And that should do the trick. I'm going to press enter. It will take us back to the cumulative incremental net monetary benefit sheet. And the reason this is not exactly minus $1,000 is because it's applying that half cycle correction. But it likes it. It's tested these and it says these are correct. So these are really important numbers. These are the total incremental net monetary benefit for treatment B for different time horizons. 1 cycle, 2 cycle, 3 cycle. If you go all the way across to cycle 60, and there's no cycle 61 here because each of these calculations takes into account the half cycle correction, right? Using the data from cycle 61 on previous sheets. But we don't need to do this up to cycle 61. Notice how that negative 18,971, that is exactly the same as what we get on the incremental net monetary benefit sheet here as our total. Because on the setting sheet, we have 60 cycles. That's our time horizon, 60 cycles. But what's really nice about this is it's effectively a sensitivity analysis on the time horizon. So that's what it would be with 60 cycles. That's what we have now. With 59 cycles, you can see it's changing. But the bad news for treatment B is that this is not cost effective. In fact, the longer the time horizon, the more incremental net monetary benefit we're losing with treatment B. So this is not cost effective at any time horizon. It looks like a price reduction might be in order for treatment B, which we will deal with later in the exercise. The last part of task 7 is step 7.2, compare the instructor's formulas to your own. So we can just scroll a little bit here. Remember, what we entered was copied across to 6, and then 7 came with it. It's very, very similar here. So you might have done something quite different. There's various different ways in which you can do the same thing, right? And so, as it says here, sometimes there are multiple different ways in which formulas may be correctly written. Once you've compared your formula to the instructor's formula and you're satisfied that they are equivalent, please tick the checkbox here. So there we go. And that brings us to the end of task 7. The next task is the final task in part 1, the deterministic results, and we'll deal with that in the next video.